Okay, welcome back. So let me continue with the discussion of profit here. So under certain restrictions, again, basically we have constant returns to scale, so we can separate it. We can separate the cost function into output and the price of value added, basically. And then we write average cost. Since there is constant returns to scale, again, this function is linear. This cost function is linear in output, so marginal cost is also equal to average cost. And then we can write the profit in this way. Now realize that as long as this is true, firm will operate, right? But also realize one thing, yj cannot be identified separately, right? In the partial equilibrium, the firm cannot exactly say how much to produce. Now remember your Econ 101. Remember this figure. So there is this figure of firm behavior in a perfectly competitive market, right? On this side, there is the firm. And on this side, we have the total market or industry. Remember this figure? This is a very famous figure. So here, we have supply and demand, right? This is price. We have supply and we have demand. And then there is this price level. Now, this price level is taken by the firm. Okay, let's say this is some price level P star. Now, the firm will take this as given, right? And the firm will have an average cost curve, right? Remember this? Remember this figure? So the how much the firm is going to produce will depend on the price and the demand, right? Factor demand. Total demand and total supply in the market. So this determines how can firm behave. So there are firms. Let's say there are n firms in this economy. N is very large. So the total supply will, of course, depend on firm level supply. And if firms will face different, now imagine a different firm whose average cost curve is here and marginal cost curve is here, right? So there could be many different firms with different cost structures, okay? Okay, and those firms will produce different amounts. As long as, again, price is above the average cost or equal to average cost under the assumption of normal rate of returns, right? There will be production. Okay, the same is going on here. So without knowing the total demand for the good, okay, we cannot solve for output at the firm level. Okay, that's the idea. Because there's constant returns to scale and profit is linear. Okay. Now you will also, of course, understand that yes, this is true. As long as this is true, firms will produce. But in equilibrium, we're gonna have this, right? Why? Because there will be excess profit opportunities if price remains higher than average cost, right? These excess profit opportunities would attract more firms entering the industry, right? More firms entering the industry results in decreasing these excess profits, okay? Again, if I go back to this figure, so if Let me just quickly create some space here. Okay, suppose that there is an increase in demand. So originally, let's say we are here. Okay. Originally, we are here. Now, suppose that there's a shift in demand. So there's a higher price. Now, this creates what? This creates a profit opportunity, right? Now, what happens? Well, new firms enter. Until when? Until price goes back to the level where it is equated to average cost. Okay? So same would be happening. So then in equilibrium, price equals marginal cost, and in this particular model, average cost is equal to marginal cost. Okay? Good. So maybe I can summarize this. Remember, this was true for the average cost. Right? Now, this was equal to average cost of J. Now, we can define this matrix V in this way. Okay. Then, of course, this is an m by n matrix. All right. And then we also have, if you recall, we also have the input-output matrix, A11, A12, dot, 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 A1n, A21, A22, dot, 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 A2n, dot, 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 AN1, AN2, dot, 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 ANN. Okay. Now, this allows me to write this equation in this way. AC, now this is true, this is the vector, okay? Or maybe I can first do this. So first, suppose that this must be equal to PJ, right? In equilibrium, again, average cost equals the price for all J. Okay, this must be true. Then I can write this in this way. P equals, now this is a vector, 1 by n. Okay. This is also a vector, price of value added. And remember that price of value added will depend on factor prices. So this is again, let me use a different color here. So this is a vector now, 1 by n. So it's a row vector. Now this also is a row vector. Okay. Now times, what do I have? I have V matrix. Now V matrix is n by n. Okay. Plus, we have what? We have again P, all right, from here. And I have what? I have A matrix. So P again is 1 by n, and this is n by 1. Now be careful. This is 1 by n, and this is 1 by n. So 1 by n is a vector, is a row vector. It can be summed with another row vector 1 by 1. At the end result, I have a row vector here. Now, if you write this explicitly, what you are seeing? Well, you are taking the first row and multiply it with the first column, right? So what do you have? You take the first row, so it is like this. Let me be much more specific. So PVA is like this. So it is a row vector. It is like PVA1, PVA2, PVA, N. And V is, again, V1, 0, 0, 0, 0, V2, 0, 0, 0, Vn. Right? You have this. Now, if you take the first row and multiply it with the first column, what do you have? PV1 times V1 plus 0, 0, 0, right? That's it. Then you have what? You have P times A. What is P? P is P1, P2, Pn, and A is that matrix, right? So if you do this, the second term becomes what? P1 times A1, 1. Again, you are taking the first column and multiply it with the first row and multiply it with the first column. So you have P1, A1, 1, P2, A2, 1, right? And it goes on. It's exactly what we require, right? Because we are requiring that the term is Pi, Ai, J. As you see, J is the same. It is 1. Okay? So then, again, we can write this equilibrium condition in this way. In matrix form. So this is called zero profit condition. Okay? And zero profit condition is necessary. Why? Because output will be determined in equilibrium, or in, to put it more specifically, in general equilibrium. Okay? Now, what's next? We want to be specific about the factor supplies, factor demands. Okay? To do this, I'm going to quickly show you some results. So I'm not going to go into detail, the mathematical details, but basically you will have this. Basically, we define this result. So xk j, so this is for firm J again. Okay. xkj Vaj, remember this? Under certain constraints, under certain assumptions, basically, again, CRS is important here. We can write this in this way. Okay? And then again, I'm just going to talk about BK in a moment. But then again, we have, remember the formula, Yj is equal to Vaj divided by Vj. We have Vj, Yj. Okay? Now, what is this BK? Well, BK is what? BK is the optimal requirement of factor K to produce 1 unit of Vaj. Okay? So, in other words, you can say this. To produce 1 unit of Yj the firm J needs, careful, Bkj W times Vj, oops, Vj units of factor K. Okay. So from this you can write this total demand, right? Total factor demand. How can you write that? So let's denote total factor demand for factor K. Okay. Now you have n firms. Right, from J1 to N. Then each firm will have this Bkj, right? W, Vj, Yj. So this is the total amount of factor K demanded by all firms. Okay. Now we denote this by where is that? Yes, we denote this as Z. I'm trying to follow the textbook's notation. We denote this as sorry, no, not that. We denote this as ZKJ WYJ. Okay. Then, of course, this can be written in this way. There's again a matrix and an output vector. I'm going to define each of them in a moment. Yes. So you have the matrix B, the matrix V, right? So B depends on the factor prices. So this is coming from that. Okay. Then you have V, then you have Y. Now Y is defined in this way. It's a column vector. It is Y1, Y2, Yn. Okay, so it is n by 1. So this is n by 1. Remember that this is n by n. So this must be k by n, right? Because you have k different factors and n different products. Look at this, Bkj, right? Bkj means you have B11, B12, B1n. Then you have B21, B22, B2n. You have BK1, BK2, and finally you have BKN. Right? So this is your B matrix with K rows and N columns. Okay, that's it. So it is all some matrix algebra. So we are going from numbers to vectors. Okay, that's it. Now for the rest, I want to leave the rest of the equilibrium discussion until next week, because that requires a lot of stuff of matrix algebra, and then we're gonna have a simple example. So next week we're gonna still working on chapter 3. Maybe I will show you the computer simulation, the computer solution. That would be nice, I guess. Now, if you have questions, I'm very happy to respond to them, or comments, or anything you want to share. Again, I want you to understand one thing. Yes, there is some notation, and it's a bit complicated at first glance, but it's not actually. It's just very simple, perfectly comparative model. Production functions and utility functions are well behaved. There's constant returns to scale in production, so we can separate cost into different components. So the total cost becomes linear in production, then profit becomes linear in production, etc., etc. So everything is actually very simple, but there is notation, and there are too many markets and too many players. Okay, just you have to make peace with that, and you must understand the vector notation, right? Let me remind you one thing. I mean, you know this, but maybe sometimes you forget. If you have a vector, that vector could be a row vector. In a row vector, we have one row and different columns. This could be a column vector as well. In a column vector, you have n rows and one column. Okay? Now, if you want to multiply a vector with a scalar, let's say alpha is some real number, okay? It is called a scalar. So if you multiply this with a vector, you can just do it. So x is equal to alpha y. If this is 1 by n, since this is 1 by 1, this will be 1 by n. You can also do this. X is equal to alpha y. If y is n by 1, this is 1 by 1, right? You can still do it. Why? Because this is scalar. You can write this as well. Okay, so this becomes n by 1. Now, if you multiply this with a matrix, let's say you have your matrix A. Let's say A is n by n. Of course, you can multiply it with y here, right? Then y is n by 1. If you define P, since P is 1 by n, you must multiply it from the left. Okay? Basically, these dimensions must be the same. Okay? And here you have 1 by 1, 1 by n, and 1 by 1. In the scalar case, of course, it doesn't really matter. But in the matrices and vectors, it matters. So we wrote z as b times v times y. Why? Because I have n by 1 here, n by n here, and k by n here. So at the end, it is k by 1, right? Each factor, for each factor, so this is like z1, z2, dot, 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 zk. Right? For each factor, there is a total demand for factor 1. Okay? So you should be careful with these left and right multiplications. Okay? Dimensions must match. Okay. So again, we have time for discussion. If you have anything, we can do it. Or if you have no input to share, I will see you next week. Again, I will continue with chapter 3, starting with the definition of equilibrium. Then we have an example.
Can I ask something?
Yeah, of course. Go ahead. You don't need to ask for permission to ask a question.
Thanks. When will the exam be?
Oh, okay. Either at the 7th week or 8th week. I don't. Maybe next week there is an exam, right?
Yes.
Okay. All right. Let me double check with the schedule, with the calendar. and I will give you, I will send you a message, all right?
Okay.
But be careful once again. You will have limited time for the exam. Don't just imagine you're gonna have like a week or something. You're gonna have 24 hours. Okay.
Okay.
So I will upload it. You will know when I will upload it. After I uploaded it, you're gonna start working on it. In 24 hours, you're gonna submit your answers. Okay.
Mhm.
All right. Then I am ending this meeting now.
Have a nice day.
Okay. You too. Bye bye.
See you.
Bye bye.